Welcome to another exciting educational video brought to you by Chrysolite Tutors. We'll be looking at Physics 124. It's a science course. Uh, the the title of the course is Geometric and Wave Optics. We'll start off with Unit 1 of this course, and it's called the reflection at plane surfaces. Reflection at plane surfaces. So in this course, we'll have this topic, we'll have this learning objective. Number one is to define and recognize incident and reflected waves or rays. Number two objective is to identify the angles of incident and reflection. Number three is to state and explain the laws of reflection. Number four objective is to understand image formation in plane mirrors. Number five is to solve simple problems on reflection. And finally, we describe how to experimentally verify the laws of reflection. So sit tight as we go through these lessons. If you're not subscribed, kindly subscribe to our channel and hit the like button so that you can always get the next video. So we are going to kick off with what is light reflection. So light actually allows us to see objects. There are two categories. We have luminous objects, luminous objects, luminous objects, luminous objects, and secondly, non-luminous objects. So the luminous objects are objects that emit their own light rays. Example, sun, candle. What else? Bulbs. All these ones can produce their own lights, emit their own light. Non-luminous objects, on the other hand, do not produce light but become visible by reflecting light from luminous sources. Examples of non-luminous is the moon. The moon is non-luminous. Why? Because it reflects the light emitted by the sun, of course, which is a luminous object. So the smallest unit of light is called a ray. Ray is the smallest unit of light. You know, when we say atom is the smallest part of a particle, or an object or a body, atom, though scientifically it's proven that atom has other components. It has the nucleus, the electrons, and the protons, and what have you, the orbits, and what have you. But the ray is the smallest unit of light. So, you know, it's proven that every object emits light. So if it's an object, for instance, it emits light out of it. Now, the ray is actually the smallest unit of light. So for purpose of simplicity and clarity, we'll be representing the ray with just single line, because they could be that the objects can emit thousands of rays. All the ray comes from the particles that make up the object. So if you agree with me that the particles are many packed together, that forms the character of the object, that form the shape of the object, physical shape of the object and physical character of the object, you see that every particle should emit light, at least on the surface of that particle should emit light. But because of simplicity and clarity, we will actually have to use simple, at least small light rays, so that it will be clear for us. So, but a beam now is a collection of rays. So if I have one ray like this, ray of light like this, now a beam is a collection. So if I have like this, this now can be called a beam. I know that light travels on a straight line, So a beam is a collection of light rays, and it can be parallel. It can have parallel beam. You can have divergent beam. You can have convergent beam, and so on. So this one I have here is parallel. Okay, this one is parallel. Let me just give us the different types. So you see that we have parallel beam. So it's like this, straight up. They will never meet. So divergent beam radiate from a point and out of that point. So this is the point, for instance, it radiates out like this. So this is divergent. Divergent means it's just divergent. It does not meet. So but convergent, on the other hand, is beams that come to a point. So they come from outside and come and converge at the point. So as the name convergent is converges at the point. This one diverge from a point. So these are the type of beams. Law of reflection. So let's consider a ray of light hitting a plane mirror. So a plane mirror actually is just a very polished surface that has a coating on one side. It's a polished surface that has a coating on one side. It's very smooth. Smooth. I'm drawing it lying down. It's a mirror. Glass, polished glass, but it is coated at one side with a silver lining like this so that the light ray cannot, go through. Going through means that it is refracted, refraction. We'll see refraction later in this course. We'll see refraction later in this course. Refraction means that the light ray goes through, and as it's going through, it bends. Like I said, light rays travel on a straight line. So we're going to consider a light ray hitting a plane mirror. So if the light ray hits a plane mirror from this direction, for instance, I'm taking one beam, I'm taking one ray, please, that's the word, one ray. Let me remove this so I don't distract you. Taking one ray, understand? If there are more than one ray, it becomes beam. So this ray hitting this thing is called the incident ray. Incident means that it goes in and hits the mirror. So it's incident, it is hitting it, it's going through, it's hitting the mirror. So the incident ray is coming towards the mirror. Let's call it A and B. So let's call it A and B. So at this point is B. So this is the point it hit the mirror. But normally, because this mirror is polished and is coated, the ray will not pass through. So it will just change its path, but it's going out again. So it's the outward ray, the one that hits the mirror or the plane surface and bounces back, is called the reflected ray. So this is the reflect. So reflection is when this same incident ray hits a polished surface and bounces out of that polished surface. That is reflection. So the reflected ray is BC. So this is B again and this is C. So there are two rays. One is AB hitting it and the other one is BC going out. So the BC bounces off the mirror. Now there is an imaginary perpendicular line on point B. So perpendicular means that it is at right angle to the mirror. So this is N. We call it the normal. We call it the normal. And that normal is denoted as N and it's perpendicular. So I have defined three concepts here. Incident ray AB, reflected ray BC, and the normal, which is perpendicular. Take note of these terms because it's going to be very useful for this course. So we'll quickly move on to the laws of reflection. Laws of reflection. Laws of reflection. So reflection is R here. Okay, so the law states that number one, I'm going to make two reference from this. The incident ray, the reflected ray, and the normal all lie on the same plane. Number one, the incident ray, the reflected ray, and the normal all lie on the plane surface at the point of incidence. incidence. So this is the first law of reflection. Hmm? First law of reflection. Okay, then second one says that the incident angle is equal to the reflected angle. Okay, number two, the angle of incident is, let me call the angle of incident I, call it I degree, is equal to the angle of reflection. Okay, now these two laws, I can, this diagram here, I can use to describe these two laws. So for the incident ray, this is the incident ray, the reflected ray, and the normal, all lie on the plane surface at the point of incidence. So where this point, where it meets like this, understand? The incident ray, the reflected ray, and the normal all lie on the plane mirror at the point of incidence. That's it. It cannot be, I cannot have incident ray here and reflected ray here and normal. No, they must be together. They must form a V shape and a perpendicular. So there must be a point where all of them will meet. So that's why I say the incident ray, the reflected ray, and the normal all lie on the plane surface at the point of incidence. Now, the second law of reflection states that the incident angle of incident, is the angle that is formed between the incident ray and the normal. So this I degree is the incident angle, and the angle of reflection is the angle formed between the reflected ray and the normal. So angle of reflection. But the law, second law, says that the angle of incident I is equal to the angle of reflection. So these two are the laws of reflection. So this is true for all reflective surfaces, especially for plane mirror. So it is true. As long as this surface is reflective and it is plane, understand? By the time you start having bent surfaces, then there will be a problem. So, so reflection at plane surfaces. So when light reflects on a smooth surface, polished surface, such as mirror, now the image is formed behind the mirror. These are the characteristics. The image is formed behind the mirror, the same size as the object in front of the mirror. The light rays diverge from the object and reflect, entering the observer's eye such a way that the image seems to come from behind the mirror. So I'm going to quickly draw something that will describe what I just said. Uh, let's say, for instance, I have, okay, so let's say I have this plane mirror like this. It's a plane mirror. Try to draw the mirror. Assume that this side is polished. This is polished and coated. Understand? Okay, so that's it. So this is the object that I want to view. Let's say I want to view this object as a candle. I want to view this object as a candle. And this is where the observer is the observer eye. That's the eye of the observer. Okay, so from what we looked at in the mirror, so that there is an incident ray from the eye of the observer that hits this mirror and it's reflected like this. So another one again, reflected like this. Sorry, I want to, that's the way this thing will look like. Okay, so it goes, this one goes and comes like this, and this second one, the second ray, hits this side and goes like this and forms. Okay, very good. I just try to draw it as much as I can. Now, um, this is the mirror, and these are real rays hitting the mirror and reflecting to this point where this one is. But if we assume that the ray of light continues like this, because A single ray cannot, light is assumed to travel on a straight line. Yes, that's the assumption. Or that is the reality. You understand? This is what is just blocking it. So let's say this was not there. This ray of light would have just continued like this virtually. So we call this virtual rays. Please, my hands need to be steady. And it forms like this. So at this point, though, where these two rays meet, it will appear that the head of this what's it called, candle, is on this side. Now this is a virtual image actually. So this is the mirror. I'll label this one mirror, and this is the eye, human eye, observing. This is the object. Object now is the candle, and this is the image that is formed behind the mirror. Behind the mirror. Now this is just a simple. What happens? What happens when you are looking at the mirror? You're looking at the mirror like this. Understand? You are looking at this object, and you are seeing the image of the object behind the mirror. So this is what happens. This is the interplay of the rays. So incident ray, the ray from your eyes hits the mirror and it's reflected. Reflection is reflected to converge at the tip of this. Of course, I said there are many rays coming like this and many rays, but we are looking at the simple ones so that two representations so that we can at least understand what is going on. Okay, so when it converges like this, the one that appears to continue virtually, will go and terminate at this point, and it will be showing this object here. Okay, now this is the image from behind the mirror. So what are the characteristics of the image? Understand? Uh, uh, for plane mirror, the image is virtual. So like I said, because of this virtual thing, the characteristics of the image form. Let me put it under here. Characteristics. My word. Number one is virtual. Number two, the same size as the object. So if you look at the mirror, it can never be bigger than your image. You understand? So same size. The image form is same size. Okay? The image form is upright. See, it's standing upright. It's not inverted. Then there is also what they call lateral inversion. I will explain that. Lateral inversion. So the image that is formed by the mirror is always laterally inverted. That is right, left, reverse. Right, left, reverse. Right, left, right, reverse. Let me use left and right, reverse. That is lateral inversion. Now I'm going to use a simple way to explain this. If you look at the mirror, and you lift your right hand. Okay, this is my left hand now. Lift your left hand. My image in the mirror will be lifting its right hand. That's how lateral inversion is. So there's a left right inversion. It's twisted. You understand? The right of the image or the right of the object becomes the left of the image, and the left of the object becomes the right of the image. The object is the real thing. The object is the real thing looking at the mirror. The image is the virtual thing behind the mirror. So I said the image that is formed behind the mirror has characteristics. It's very important to know that in this course. First of all, image from my plane mirror. One, it is virtual. Why? Why is it virtual? Because behind the mirror, it's not real. Secondly, it's the same size of the object. So the image you are seeing behind the mirror is the same size. The same big head is formed at the other side. The head is big in the object, is big in the image. It's not as if you have big head and you have small head. That's just a joke. Okay, so same size and the object. The image formed is upright, that is standing upright, so the head is up and the head there is up. And lateral inversion, the only thing that is twisted is the left right orientation. Okay, so like I said, check this up in the mirror. Check, do your mirror exercise. Go to your mirror and check, is your image real or virtual? Yes, of course it's virtual. Check, because what you have inside the mirror is not the real you, as in the real image. It is you reflecting inside the mirror, but it is virtual. It's not. It cannot eat food. It doesn't have its own mind. It's only doing what you are doing because it is a reflection of you. It's a virtual image. So the image is virtual. Is your head pointing the same direction as the image? Yes, of course. Look at the mirror yourself. Of course, you have been looking at the mirror all the while of your life. You see that your head is always up, not down. So which side of your image corresponds to the right, your real right hand? Like I said, if I lift up my right hand before the mirror, the left hand of the image in the mirror will be lifting up instead of. So are you the same size as your image? Check that out too. All right. So we have seen that. We are going to also be verifying the laws of reflection um, with a simple experiment. Okay, so we're going to be trying to verify the laws of reflection with these materials. You have a white A4 paper, a plain mirror, three pins or matchsticks, ruler, and a pencil. So you have your mirror. You place your mirror vertically. Let's say this is the mirror. Place it vertically on the paper. So this is the mirror. So it's like on the paper. You can understand what I'm doing here. So you have the mirror. This is the mirror, and it's on the paper. The paper is just like this, somewhere, somehow like this. Okay, so the next thing we'll do is to mark a point. So just place one of the pins on this point, and you will see that this is the pin. So this is the object. This is the object. Then there's a reflection here actually, but you just try to place the second one, align, and then you place the third one somewhere here. So actually, the image that you are seeing on the mirror, this follows it, and this one goes out. So what we're trying to do is that we're trying to discover whether that thing we said about uh, uh, angle of incidence, angle of reflection, all lie on the same point at the point of incidence with the normal. Understand whether the angle of incidence and angle of reflection is the same. This is the practical demonstration with these materials. Understand? So by the time you go through, you draw the lines, and then when you remove what you have the mirror from the plain paper, you see the lines geometrically. The line that goes through to that is how did you come across, how did you get this line? You got the line by aligning it. The object you are seeing, the image you are seeing at the back of the mirror, your eye should be able to see this, and there's no parallax. You're not seeing any, you are seeing it from this angle, and you're not seeing this one aligned. So you are trying to place this one until you are not seeing this one behind this one. Understand? That is where you can now commonly draw the line to lead to this point, and also draw the line to lead to this point. So by the time you remove the mirror, you actually see the traces of the line you have drawn with your pencil and your ruler. And by the time you divide this into two equal parts, this is normal. You see that the angle of incidence and angle of reflection is the same or almost the same, barring any error from this kind of experiment. So we have been able to see in these lessons that light rays are the basic unit of light traveling in straight line. We have seen that in this video. We've seen that a beam is a group of rays, parallel, divergent, or convergent, depending on the configuration of the beam. We see that a reflection occurs when light bounces off a surface. And the laws of reflection, there are two. You have the number one says the incident ray, reflected ray, and normal all lie on the same plane. Number two law says the angle of incidence equals the angle of reflection. Plane mirrors form virtual images, upright images, laterally inverted images, and image of the same size and at equal distance from the mirror. I didn't want to put that equal distance from the mirror. So the image distance from the mirror that's behind the mirror is same thing to object distance from the mirror. So very, very important. So uh, please go to this video. Thanks for watching. Don't forget to like, share, and subscribe. Chrysolite Tutors for more clear and helpful explanation in physics, mathematics, and more. Drop your questions in the comments and let us keep learning together. See you in the next class.